Okay, well, I talked about this in class, but I want to go ahead and do this as well on video. So that way we're hopefully all on the same page. If there's any questions, hopefully this video will help you out. But you do need to have your ruler, and you need to also have your color pencils or something like that. You need colors, crayons. You need some different colors. Trying to substitute is not going to cut it. I know that y'all got matte pencils or color pencils at the beginning of the school year. I know y'all got rulers at the beginning of the school year. So please have your stuff ready. Okay? Also, this will count as a lab grade. Since it's a lab grade, I am going to really grade it and take points off for not having the correct colors. Okay? So don't sit there and try to make me a new color key code for your new colors that you're going to use. No, use the colors that I gave you. Okay? If you're a Tuesday person, you need to print out the Tuesday paper. If you're a Wednesday person, you need to print out the Wednesday paper. But you need to make sure that you print out the correct worksheet for your day of the week. So everybody has this part that's the same. Let's look at this part, and then I'm going to start talking about the bottom part. That's when we're going to start to be a little different depending on which class you are in. Now over here, let's go ahead with your worksheet. Let's label a few things. This is going to be our amplitude. Our amplitude is how high up or how far below the equilibrium line. And this is our equilibrium line. Equilibrium means that it's at rest. So how high up or how far below it. Now the amplitude is determined on the amount of energy that wave has. The more energy, the higher the amplitude. Now, for an example, from middle to middle, this section right there is going to be a wavelength. Let's go ahead and write that in, wavelength. Over here, this is our crest, and at the bottom, this is our trough. Okay, so I think we kind of have pretty much most of the stuff labeled. Let's go ahead and start answering the questions. First part here, the amplitude, measure the energy of the wave. How high does the wave get? How that height is due to the amount of energy that wave has. It's measured from the equilibrium position, which is that line all the way across the middle, to the top, or from the equilibrium to the bottom. Now we're going to use a ruler, so a ruler's in centimeters, right? Not inches, so let's go ahead and move it over to the centimeters. And you need to also convert it to meters. It's telling you to do that. So let's go ahead and let's measure it in centimeters. My centimeter over here on my ruler, my line is over here, so please make sure that you line up the top of it to this line. My ruler does not start at the end of the ruler. My measurement starts over here at this line. So please, I am going to take off. I'm going to allow you to go 1/10 over or above, under or above, but that's about it. This measurement should be fairly simple. So let me come over here. Let me find the top. And I'm going to zoom in so that way we all can see this. I want you to be accurate. So at the top of my line, which starts right there, not at the end of the ruler, and it goes all the way down, 1 point, ooh, that's in the middle. Let me make sure. Oops. Let me reline up. I keep moving my ruler over here. I'm going to make sure that I'm lined up correctly. At the top of the crest to the equilibrium, and I think my ruler's a little bit off. I don't think it's straight. There we go. I've got 1.1. Okay, if you gave me 1.2, I'm okay with that. But you can definitely tell that it's not 1 even. It's not 1. It's below the number 1. Do not be lazy. I'm going to take points off. This will count as a lab grade. So 1.1 centimeters is my answer. Let me zoom out for you so that way you can see what I have. 1.1. Now, if you need to, let's go ahead and write this at the top of your paper. King Henry drinks utterly delicious chocolate milk. I'm starting off at the centimeters and I'm going to convert to meters, which is the base unit. So here's where I'm starting off at. I'm going to move it 2 places to the left. So it was 1.1. Let's move the decimal 2 places. My new number is 0.011 meters. That's my answer. Now the next question says wavelength. Now wavelength has an abbreviation, which is a lambda, that little weird Y, upside down Y. The length of one wavelength could be crest to crest, or it could be trough to trough, or it could be from middle to middle. So middle to middle, crest to crest, or trough to trough. Any one of those 3 locations is a good wavelength, okay? And you can measure any part of it because they're all the same width. Now let's go ahead and use our ruler again. I am going to take off for not being accurate. Please make sure that you are accurate. Don't forget, my ruler does not start off at the end of the ruler. I start off over here on this line. So I need to make sure that I line up there. And I'm going to go ahead and go from crest to crest. Let's see. And let's zoom in. From crest to crest, it's right about here. So 3.5 centimeters. Let me zoom out so that way I can measure it myself just to make sure. Let me get my ruler, take my measurements, because I want to double check. We all should have the same answer for this one. 1, 2, 3, 3.5 centimeters. Everyone should have 3.5. Now convert that to meters. Move the decimal place over 2 places to the left. 2. 0.035 meters. How many crests are there? 1, 2, 3, 4. How many troughs? 1, 2, 3, 4. Now let's go ahead and find the velocity of this wave. Now if this wave took a total of 5 seconds to complete, what is the velocity of the wave? Well, my equation for velocity is lambda times frequency. Now do I have frequency? I don't. Do I have the lambda? I do. I have the lambda. So let me go ahead and do step 1, which is finding the frequency. Now to find frequency, it's 1 over period, but they didn't give me the period. So what is my other equation? The number of waves over the amount of time. So how many waves are there? Well, let's go ahead and let's check that out and count it. From here to here is 1 wave. From here to here is 2. Here to here is 3. And then from middle up, down, middle is 4. So there's a total of 4 waves and it took 5 seconds to complete. Okay? 4 waves and a total of 5 seconds to complete it. My answer comes out to 0.8. Now, this is my frequency, which is in hertz. Now, to solve for velocity, I'm going to get frequency, which is 0.8, multiply it by the lambda. What is the lambda? Well, you have 2 choices. You can either use the centimeters or the meters. Now, preference is the meters, but centimeters is okay. If you use centimeters, you better use the correct SI unit. So I'm going to go ahead and put 0.035 meters. So 0.8 times 0.035 comes out to 0.028 meters per second. But again, you could have done this in centimeters if you preferred. That's okay. Make sure you use the correct SI unit. Now let's go ahead and let's begin looking at this worksheet. This may be a different worksheet or a different picture than yours, but they're going to look similar. The questions are going to be similar. Okay, the colors are going to be different. So let's look at this one. How many waves are there? Well, I start here at the left, and since it's starting from the middle, I'm going to go from middle, up, down, middle. That's 1. Middle, up, down, middle. 2. Middle, up, down, middle. 3. So 1, 2, 3, 4, 5. So I have 5 waves myself. Count your worksheet, and your worksheet's probably going to be different. Count up how many waves you have. I need to find my amplitude, which is from the equilibrium up or from the equilibrium down. I need to convert it to meters. I need to find the wavelength, which is crest to crest or trough to trough or middle to middle. But I need to also convert it to meters. They're asking you how many crests. Well, let's look. 1, 2, 3, 4, 5. How many troughs? 1, 2, 3, 4, 5. Use a blue color to trace one complete wavelength. I'm gonna take points off if you do not follow the directions. You need to color it your color that you were told, and you need to do only one wavelength. If you do the whole thing, it's wrong. One complete wavelength. Where, I do not care. But for me, I'm going to go ahead and just choose here, and I'm going to go top, all the way to the bottom, all the way to the top. That is one complete wavelength. And I did it in blue. You do yours in whatever color that you're supposed to, but if you do it in the wrong color, I'm taking off. Okay. The next one. It says here, using the brown color, go ahead and circle each of the crests. I'm doing what my worksheet says. I'm going to get brown. You use whatever color your worksheet says. It says put a circle around each crest. If you only do one, then it's wrong. Here are my crests. And I did it in brown. The next one says use a pink color and go ahead and put a box around each trough. It doesn't say one trough. It says each trough. So 1 box, 2 box, 3 box, 4 box, 5 box. Now I'm going to go to the next question, and it says go ahead and let's actually find the velocity of this wave train. If the wave train took a total of 3 seconds to occur, okay, find the velocity of this wave. Well, in this case, I need to, number 1, find frequency. They did not give me period, so I need to solve it by using the number of waves over the amount of time. So let's go ahead and do that. How many waves do I have total? Well, over here in part A, they tell you 5 waves, and down here it tells you that it took 3 seconds. So 5 divided by 3 comes out to 1.66. Now, this is hertz because this is frequency. That's not my answer. Now I'm going to come over here and solve for the velocity, which equals frequency times lambda. Frequency is 1.66. What is my lambda? Well, let's go ahead and solve. Well, we don't have to solve for it. It's over here on part B. You can use meters or centimeters, and you're going to do it just like how we did above over here. So with your ruler, using your centimeters, not your inches, for my worksheet, I've got my lambda at 3.9 centimeters, which makes it 0.039 meters. So I'm going to use 0.039 meters. I'm going to multiply those numbers together. My velocity for me, yours, is going to be different. 0.065 meters per second. And that's my correct answer. Follow along with your worksheet because your worksheet is going to be different. Again, make sure you color it correctly. As you continue to read all of the questions, they're all going to switch up the colors. They're all going to be different. So please make sure you pay attention before you just randomly start to color. Okay? So let me post this for everybody. This is due Friday at 1 p.m.